Hi, I'm Veronica.
And I'm Maya.
Just kidding, but that was the stroop effect. My name's Maya.
And I'm Veronica.
And I'm Erin. Welcome. In this presentation, we will be teaching you about the stroop effect, including what it is, how it is present in our everyday lives, and how it's related to motor behavior. The stroop effect was named after J. Ridley Stroop and was discovered in the 1930s. The stroop effect is defined as the presentation of a task and the time that it takes to complete that said task. The most commonly found use of the stroop effect is when words are written in a different color from what they say. For example, the word red being written in blue ink. Often it can be hard to recognize this difference, and many people say that the word that they are reading rather than the color that they are seeing. Most people think that their mind is playing tricks on them when they reach this confusion, but really our brains are just too overloaded. This happens because of the interference in your brain when you are receiving two different sets of information at the same time, what the words say versus the actual color of the words. Two reasons why this interference may occur are because the speed at which we read words is faster than that of naming colors, and because naming colors requires more attention than reading words. Because of this, naming colors takes longer than normal, and people are more prone to errors when trying to name the colors. Let's explore some other ways that the stroop effect has a presence in our daily lives.
The stroop effect is an example of how our information processing systems interact with the study of motor behavior. The stroop effect supported the filter theory that explained how the three components of information processing may overlap. The three components contain stimulus identification, response selection, and response programming. The stroop effect supports that we direct attention and process information simultaneously, known as parallel processing. It is said that the stroop effect occurred in the stimulus identification phase, which contains encoding of sensory and storage and perceptual analysis. The concept further helped the realm of motor behavior because of its relation to reaction time and interferences. Congruency, when a word and the color are the same, decreased reaction time. Incongruency, when a word and the color are different, increased reaction time. Perceptual analysis of the color in the word presented resulted in a different response selection and therefore would increase reaction time with incongruency.
The stroop effect studied word recognition and cognitive control within monolinguals, bilinguals, and multilinguals. Recognition, speed, and verbal susceptibility are three very important key factors when testing the stroop effect. Monolinguals have an advantage in word recognition as a result of only speaking one language, whereas bilinguals struggle with slower word recognition, although they often switch between the two languages on a daily basis. Many factors also play into bilinguals and the stroop task. These could be things such as age, sex, and gender. Gender plays a significant role in performance on stroop tasks. Females have shorter latencies, which mean they process information at a faster rate. This is beneficial when testing the stroop effect because time is a major component. Females were able to recognize words and colors quicker than males. Women are able to process these things at a more rapid rate due to the verbal and fine motor skills we possess. Linguistic tasks and the stimuli in the saccadic stroop effect focused on our oculomotor control as well as cues that were given. As our linguistic cues are based on our language, this closely tied with bilingualism and how we approach tasks. If a bilingual individual heard a task in only one language but had to reflect back in their second language, this could decrease the time of the word recognition and cognitive control. This could lead to a biased effect, yet still be effective for the stroop task. The symbolic cues used would track the individual's eye movement within the saccadic stroop effect, leading to cognitive influence.
So here are some questions that we still have and things that we would still like to understand about the stroop effect.
So I think it's really interesting linking the stroop effect and sign language and how that would work and if it would present the same type of information processing that we use within the stroop effect in bilinguals.
I'm really interested in what Maya's interested in as well, with American Sign Language being a second form of English, but it's also different by we use our motor patterns and our fingers, and it's a whole different visual stimulus. So it'd be really interesting to see how that correlates with being able to read sign language and then being able to read and write written language as well.
Individuals that are deaf and use sign language use a different form of writing called glossing. And glossing is a little bit different than how we write things, such as papers and articles, so I would really like to see how that ties in with reading things and the word recognition within that.
And that's not something I knew, so I just learned something already.
I would also like to know how reaction time within the stroop effect might affect performance with sports and application.
What types of sports would you like to see that in?
Perhaps track and field. When they do the gun, you know. We're honest.